Hello. I've had a couple students recently approach me about this diagram I use to help remember a couple essential trig identities. This diagram was actually given to me by a student that I taught once. I will say, when I was in high school, I found trig identities hard. So if you're finding them hard right now, don't let it discourage you. Stick with it. Keep practicing. The key is just sticking with it with trig identities and not being afraid to go back and try again. So this diagram is going to help you remember your reciprocal identities, your quotient identities, and your Pythagorean identities. So it kind of looks like a radioactive symbol. And once we've drawn it, what we're going to do is we're going to put ratios on the end of each line. So we start with cos, sine, tan, and one way to remember this is starting with cos, it's alphabetical, and then across the diagram is the reciprocal. So the cotangent across from cosine is secant, across from sine is cosecant. So the first thing that you can read from this, we put a 1 in the middle. So again, 1 in the middle, cos, sine, tan, and then directly across is the reciprocal. So the first thing we can read from this is the reciprocal identities. So I see that, for example, cosecant theta is equal to 1 over sine theta. Cosecant theta is 1 over sine theta. Secant theta is equal to 1 over cos theta, and cotangent theta is equal to 1 over tan theta. So there's your first set of identities that you can get directly from this. Of course, you can write your reciprocal identities slightly different. You can actually write them in terms of the primary trig ratio. So sine theta is equal to 1 over cosecant theta. Cos theta is equal to 1 over secant theta, and tan theta is equal to 1 over cotangent theta. So that's the first useful piece of information from this diagram, is directly across is the reciprocal identity. Okay, you can read it. Sine theta is 1 over cosecant theta. Secant theta is 1 over cos theta. Next is the quotient identities. Now this is one I didn't actually initially learn. The student pointed out to me. So this doesn't work everywhere, but if you start on say this branch here, and this only works if we move in a clockwise direction, we can say tan theta is sine theta over cos theta. So the first quotient identity is tan theta is equal to sine theta over cos theta. And this is what most students memorize, which is great. Well, it turns out also cos theta can be written as cotangent theta over cosecant theta. And then finally, cosecant theta can be written as secant theta over tan theta. So there's your quotient identities. Okay, most students learn this one, but these other two are useful as well. The last thing that this diagram gives you, and there very well could be some other little tricks in here that I haven't seen. Every time I show this to a student, they seem to point out some other interesting relationship, is you can actually pull up the Pythagorean identities. And the reason why I say identities is because there's actually a couple of them. This is the one most students learn. Sine squared theta plus cos squared theta equals 1. And so the way we read this is you have to stay on one of the radioactive branches here, and you read, if you go across, you add, and then it equals whatever's below it. So sine squared theta plus cos squared theta equals 1. And we can work here as well. Tan squared theta plus 1 squared is secant theta. So we often say tan squared theta plus 1 equals secant squared theta. And our last one here, 1 plus cotangent squared theta equals cosecant squared theta. 1 plus cotangent squared theta equals cosecant squared theta. And those are your Pythagorean identities. Again, students mostly just learn this first one, but these other two are really useful. And often when you get that tricky question that's just a slightly more harder, is it will use one of the Pythagorean identities. So again, a great little diagram, and I'll draw it once more just to clean it up, so to get all the writing off of it. The way to draw it out is you start with a circle and you put a 1 in it, and then you make a radioactive symbol. Let's make this a little neater. You make a radioactive symbol. Starting here, I go cos, sine, tan. I remember this because it's alphabetical. And then you would go across to write the reciprocal identities, cotangent, cosecant, secant. And then using this diagram, we can get a reciprocal, a quotient, and our Pythagorean identities. As always, if you have any questions, please don't hesitate to post a comment or just ask me. Have a wonderful day.